Question 3, IAL Edexcel M1 June 16. Part A is straightforward enough. We've got a block being released from rest and above from a height A. For this purpose the mass doesn't matter, but we'll need that in the next part. But we're given the velocity that it strikes another block B at. So we have something being dropped, block A, onto block B, which is on the ground. So, and we're told that the length from block A to block B is h, and we're asked to find h given that the velocity here is 7 meters per second. But of course it's released from that rest, so we've got u equals 0. So we can just apply v squared equals u squared plus 2as. And so we have 7 squared is equal to u squared, which is 0 squared, plus 2 times g, which is always 9.8 in M1, and divided by h. Rearranging that, we get h is equal to 49 over 2 times 9.8. So that gives us 2.5 meters. Okay, so that was a pretty straightforward part, just for 2 marks. Questions like part B do come up from time to time. I sometimes call them pile driver questions, where something's driven into the ground with rapid deceleration because it's been slowed down by resistances. It says immediately after the impact, the block moves downwards together with the same speed, and both come to rest after sinking a vertical distance of 12 centimeters from the ground. So basically it's been moving into kind of solid ground, and of course the resistances are going to be huge for that. So we've got basically the 2 blocks together now with resistances R. The ground is basically resisting it moving in towards it, but it's also got weight 10.5 g together, but because it's got 9 kilograms and 1.5 kilograms, so the combined weight is 10.5 g. So those are the forces on the thing. R is going to be causing it to rapidly decelerate. So A is in that direction. It's going to be decelerating but moving down initially with this acceleration 7 meters per second. Okay. Oh no, that's not quite true, because the key here is we're going to have to actually apply momentum again before we get to this stage, because what happens is before A collides with B, we will have A moving with 7 meters per second and B moving with 0 meters per second, and then afterwards they will combine together with a combined speed. Let's call that V. It's not 7, of course. So if we apply conservation of linear momentum again, we can say 7 times by the weight of that block, which is 9, plus 0 times by the mass of the block, which is 1.5, will be equal to the combined mass, which is 10.5 V. So V equals to, working that out, that's 63 over 10.5, which is equal to 6 meters per second. So it's not moving, it doesn't, just at the point where this goes into the ground, the speed is actually 6 meters per second, not 7 as I originally said. So lots to think about with this question. So 6 meters per second. Let's just try and tidy this up a bit, so I've got a bit of space. So there we go. Just to reiterate, now this is beginning, this ground is soft, so it's going to start kind of going into this ground, but the ground will be stopping it from going in too far. It only goes 12 centimeters, which is 0.12 meters into the ground. So it kind of penetrates into the ground a bit, makes a little bit of a hole into the ground, and moves 0.12 meters until it comes to rest. Okay, well, I'm going to work out this deceleration, or the acceleration, and then work with that, and work out that acceleration first, or deceleration, and then we can just use F equals ma to work out r. So to work out the acceleration, we use the fact that it's moved 0.12 meters, 12 centimeters into the ground before coming to rest. Now the initial velocity is 6, because we've just worked that out, because it's the combined velocity of the two masses after impact of A and B. The final velocity is 0, because it's come to rest after 12 centimeters. S is equal to 0.12, and we want to work out the acceleration or deceleration. So the equation we're looking for, again, probably the most commonly used one in M1, but all of them are used at some point. V squared is equal to U squared plus 2AS. That's 0 squared is equal to 6 squared plus 2 times by A, which is A is unknown, and S is 0.12. Now, rearranging that gives me A is equal to 36 over 2 times 0.12. So that equals to minus 150 meters per second squared. It's rapidly decelerating. It's going to come to a halt pretty quickly because it's going into ground. So that's why that number is quite big. So now it's just a matter of using F equals ma with deceleration. I'm going to go downwards, but we could do it upwards. I'm going to apply it downwards. So if I call all the forces downwards positive, I've got the weight going downwards. I've got the resistances going upwards is equal to the mass, and the mass is 10.5 times by minus 150. So R, rearranging that, is 10.5 times 150 plus 10.5 times 9.8. Rearranging that. So that gives me R, pretty big force, 1680 newtons to 3 significant figures. You can also write 1700 newtons, but nothing else for that answer. So you will see questions like that from time to time, not that common, but you just apply the principles, it's fine. Just know that the acceleration is pretty big, and the resistive force is pretty big as well. It's a large, acceleration is big in magnitude, it's decelerates rapidly. Okay, let's do the next question.